Okay, so now let's talk about load balancers on AWS. So you have four kind of managed load balancers. You have the classic load balancer, which is old generation, which supports HTTP, HTTPS, TCP, and SSL, which is secure TCP. You have the ALB, application load balancer, which is V2, new generation, and it supports HTTP, HTTPS, and WebSocket. You have the network load balancer, also newer generation, which supports TCP, TLS, which is secure TCP, as well as UDP. And then you have the Gateway Load Balancer from 2020, GWLB, which operates at a lower level, so layer 3, which is a network level, the IP protocol. Overall, it's going to be recommended to use the newer kind of generation load balancers versus the classic load balancer as they have more feature and they're going to be supported by AWS over time. We're going to do a deep dive on all of those in this lecture. Finally, some load balancers can be set up internally as private or externally as public ELBs. So the first one is the classic load balancer, and you have health checks on it. They can be at the layer 7 with HTTP or at the layer 4 with TCP, including based on SSL. It supports only one SSL certificate, which is a problem, but the SSL certificate can have many subject alternative names, so SAN. But in that case, once you want to add or remove a SAN, then you need to update the SSL certificate with all the subject alternate name. It's not ideal, and therefore, that's why it's recommended to use the newer ALB, which has SNI, server name indication, if possible, because you're going to be able to use multiple SSL certificates on an application load balancer. And if you want to have distinct SSL certificates, then from an architectural perspective, you must use multiple classic load balancer. In case you're doing TCP to TCP traffic, then all the traffic is going to go directly into the EC2 instance. It's going to be transiting through the CLB. And this is the only way you can do two-way SSL authentication on a classic load balancer. So the SSL authentication happens at the EC2 level. So to summarize, the client talks to the CLB, which talks internally to the EC2 instance. Next, we have the ALB. So it's layer 7, only HTTP, and you can load balance to cross multiple machines in a target group. Now, the load balancing can also happen to multiple containers on the same machine, which makes it a great fit to be using with the ECS service, which leverages the dynamic port mapping feature of the ALB. It also has support for HTTP version 2, as well as the WebSocket protocol. And you can have some sort of rules and redirects. For example, you can redirect from HTTP to HTTPS directly at the application balancer level. But you can also write your own routing rules, such as path, headers, query strings, and so on. So if we know an example, here we have an external application balancer v2 and two target groups, one for the users that is accessible at the root/user, and the other one for search, which is available at the root/search. And as you can see, each target group will have a different health check. Okay, so what are the targets of an ALB? They're target groups, and it could be either EC2 instances, and these instances can be managed by an auto-scaling group. This is a very common pattern. It could be ECS tasks managed by ECS itself, again using HTTP, or it could be Lambda functions, in which case your Lambda function, your HTTP request is going to be translated for your Lambda function into a JSON event. Then it could also be IP addresses. In this case, you must register private IP addresses as targets of your ALB. Your ALB can also route to multiple target groups at a time, and you have health checks, as I said, at the target group level. Next, we have the network load balancer. It's layer 4, and it allows you to forward TCP and UDP traffic to your instances, and also to handle millions of requests per second. So it's very high performance. It has less latency than the ALB, around 100 milliseconds versus 400 milliseconds for the ALB. And with the NLB, you're going to get one static IP per availability zones, and it supports assigning elastic IP as the public IP if your NLB is public. So as a use case, NLB are going to be extremely helpful when you need extreme performance, such as for TCP or UDP traffic, and the NLB is not included in the AWS free tier. For target groups, for the NLB, you get EC2 instances, so they get registered directly with the NLB and you're good to go. It could be IP addresses, so in case you have, for example, some on-premises servers you want to register by, or if you wanted to register your EC2 instances with the private IP, you could do this as well. Or finally, a target of your NLB could be an application load balancer. And the use case for this would be to leverage the features of the ALB with, for example, layer 7 routing, but you want to keep the static IP features of your network load balancer. So you would chain them together. It's a very common pattern. Now, another one is around zonal DNS name. So if you resolve what's called the regional NLB DNS name, which is the DNS name you would use by default, then it's going to return all the IPs for all the NLB nodes in all the enabled AZs. So this is your NLB DNS name. And so if we have the NLB here enabled in 3 AZ, and we do a DNS query for this NLB DNS name, then we're going to get 3 IP as a return, which will correspond to the 3 AZ that are enabled. But sometimes you may want to resolve the zonal DNS name. And the idea is that the NLB has DNS name for each of their nodes, so based on the availability zone. And using this zonal DNS name, we can resolve only one IP address, which is the IP address of each node. So for example, if you wanted to know what was the IP address of the node in US East 1A, then you would add US East 1A to your DNS name, and then it would return only the first IP. So why would you do this? Why would you want to resolve a specific node? Well, this could be, for example, to minimize latency or data transfer costs. For example, say you have an application and it's deployed on your VPC in 3 different AZ, and it's going to then talk to an NLB. Then you absolutely want, for example, your instances in US East 1A to talk to the NLB node in US East 1A, because there's going to be no data transfer cost and lower latency. So in that case, you would resolve the zonal DNS name for your NLB and only find the one IP that will ensure you don't have any networking cost. Because if you use the regional NLB name, then there's a chance for you that your application sends traffic from one AZ to the other one, therefore incurring some cost. So to make sure your application sends traffic to the right NLB node, you need to implement application-specific logic. Your application needs to understand in which AZ it is operating from, and then how to query the right DNS name for your NLB. The last kind of load balancer is a gateway load balancer. It's used to deploy, scale, and manage a fleet of third-party network virtual appliances in AWS. So the use case for a gateway load balancer is to do firewall, to do intrusion detection and prevention systems, to do deep packet inspection systems, or payload manipulation. It operates at the network layer, so layer 3, which operates directly on the IP packets. And it combines the following functions. It's a transparent network gateway. That means it's a single point of entry and exit for all traffic. And also it's a load balancer because behind the scenes, it can deploy and distribute the traffic to your virtual appliances. As a technical thing, it uses the GNIF protocol on port 6081. So a diagram will make it super helpful. So your users wants to access your application, which is the destination, but you want to scan all the traffic using third-party security virtual appliances. So how do you do? Well, you deploy a gateway load balancer and you edit your route tables. Now, all the traffic is going to go through your gateway load balancer. The target group of the gateway load balancer is going to be these third-party virtual appliances, and they're going to receive all the traffic, analyze it, and if it's good, keep on sending it back to the gateway load balancer, which is going to forward that traffic back to your application. So here, the added benefit is that all the traffic is going to go through your third-party security virtual appliances. So the target groups for your gateway load balancer could be EC2 instances, or it could be IP addresses, and it must be private IPs. So that's it for an overview of all the load balancers on AWS. I hope you liked it, and I will see you in the next lecture.